the last chapter of this course, chapter 10. What we're going to do is we're going to again make decisions like we did in chapter 1, part 2. And we're going to take our data, we're going to interpret it, and take those results, and we're going to use that to make decisions. So, in order to do that, we have to be able to identify our two hypotheses. The null hypothesis is that statement of no difference. It's what is status quo, and it contains typically the equal sign. However, we could do yes, less than and equal to, or greater than or equal to, but we'll just stick with the equal to sign. The alternative is that statement of difference. It's why the researcher is conducting the study. What is it that they are finding different than what's already out there and believed to be true? The alternative will have the not equal to sign. If you recall, that's a two-sided. I'm not sure if it's a bigger or smaller. A greater than, which would be larger or to the right. A left than, that would be smaller or to the left. A little bit more practice in computing these because we'll have to have those directions in order to make the test work. In Let's Do It 10.1, the median age of patients in the hospital is more than 60 years old. So the null and the alternative, what we need to find from that. So we need to go back into the question that says, these statements are the researcher's claim. So the researcher is claiming that the age is greater than 60 years old. So the alternative is that the age is greater than 60. Opposite of that is that the age is less than or equal to 60. So if I'm at 60, I'm with the null hypothesis. Again, this is the researcher claim. The mean caffeine of a cup of coffee is less than 110. So that is the alternative. So less than 110. So that would be the caffeine content. So the null would be that it is greater than or equal to 110. In the last example, the average number of emergency room admissions on a day differs from 20. I'm not sure if it's more than or less than. Not equal to 20, or this would be equal to 20. Now, if these two symbols are bothering you here, you could put equal to if you would like. That will be fine for our test. What we're most worried about here is our alternative because it tells me the direction that I'm looking for. Where are my extreme values? In other words, if I look on this curve and I get greater than 60, 60 is my cutoff for when I'm going to reject. So that is on my right. In the second scenario, if I'm looking for where I am less than 110, or so it says greater than right, less than 110 is on this side, which is on the left. So we call that a left direction test. In the last scenario, I'm not sure if I'm greater than or less than 20, so I'm looking at being small, very small, or very large away from 20. So this would be a two-sided, and we're going to need to know that in order to perform a hypothesis test.